All right, guys, 3.3 homework. Here we go. So this one, a lot of it's just about fractions and decimals. So on our first page here, for number 2, we want to write the decimal and the fraction equivalent for what is shaded in. So in class, we said, well, let's just see how much is shaded in. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So first of all, we can see that we have 30 shaded in. And how many are in this whole unit? 100. So our first fraction might be just 30 out of 100. 30 hundredths. And then we can write the decimal for 30 hundredths, right? That means we need to see 0.30. And how do we know that's 30 hundredths? Because it goes tenths, hundredths. Then thousandths would be next, but we don't need thousandths. And since our decimal ends in the hundredths spot, that means that's 30 hundredths. You know, and then some students also said, well, could I also just simplify that to 3/10? Sure, we could divide both those by 3. And that means we could also write the decimal 3/10. Again, just in the 10th spot. So all we're doing is seeing how much is shaded in. Give me a decimal and a fraction. And you don't have to even simplify your fraction if you don't want to. Just anything that would be equivalent to that. So B, if you want to kind of count how many you got there, a couple ways we could write that. For C, they're telling us that they want 2/10. You know, so 2/10, I already know I could write as the fraction 2/10. You know, and we could also think about these as 10 rows, right? 10 columns. We got 1, 2, 3. Here, let's go to this real quick. You know, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You know, there's 10 columns here. So 2/10 would just be 2 of those. So we could just shade in 2 out of the 10. And our first quiz talks a little bit about how can we think about this as tenths. So that's 2/10. We could also say, hey, we shaded in 20 of those boxes, right? That'd be the same as 20 out of 100. So just a couple ways we can think about that. You know, we could also say this decimal could also be thought of as 20 hundredths. But again, that's the idea, is we could think about each individual little box, like 100 pennies in a dollar, or think about 10 dimes in a dollar, however you want to think about it. So for this one, right, we would just shade in these first 2. Or you could shade in, hey, if you want to make a design, you got to shade in 20 boxes altogether. So however you want that to look, that would work fine. And then 60 out of 100. Well, if I shade in 60 out of 100, what would that look like? And then what would my decimal be? All right. Number 3, Julian walked 6/10 of a mile to his friend's house, then another 35 hundredths of a mile to the store, then a quarter of a mile back home. How far did he walk in all? Now, Julian's sister said that he walked 1 1/5 miles. So we set this one up. Well, let's see, 6/10 plus 35 hundredths plus 1/4. According to his sister, that's going to be 1 1/5. So let's see. So we got to get equivalent fractions. One thing we could do is we could just do 100 for all these. So we could keep that 35 hundredths. So 10 times what is 100? 10 times 10. So we got to multiply up here by 10. So we could get 100. And then 6 times 10 would be 60. How about this 4? 4 times what is 100? 4 times 25. So we got to do 1 times 25 up here, right? Again, it's all about equivalent fractions from last unit. 4 times 25 is 100. Up top, 1 times 25 would be 25. Now that we have common denominators, we can go ahead and add these up. So we got a 60, a 35, a 25. Let's see, 5 and 5 gets us to 10. 6, 7, 8, 9, 10, 11, 12. So it looks like we have 120 over 100. Okay? So it is an improper fraction, so we do have at least one whole, so his sister might be right. How could we simplify this? Remember that 120 was kind of like 100 hundredths plus 20 hundredths. That 120, if I have 100, that's one whole, and then I've got 20 out of 100. Okay, so how can we simplify 20 hundredths? Well, we can divide by a common factor. In this case, we could divide by 20. 20 goes into 20 one time, and 20 goes into 100 5 times. Okay, so we had 100 hundredths. That's one whole. And then we said that 20 hundredths is the same as 1/5. So it is true that we would get 1 1/5. So that's kind of how we've been doing it in class, is keeping the larger denominator. Let's look at another way real quick. How about this 35 hundredths? We know we could also maybe divide by 5 on these. So 5 times what is 35? That'd be 7. And then what's 100 divided by 5? That's going to be 20. So, if you want to go to 100 for a common denominator, that's fine. Or it looks like we could have kept 20 as a common denominator. We could have kept 20 as a common denominator if we wanted to go this route. So again, we had 6/10 originally, and then we said 35 hundredths. Hey, that's the same as 7/20. And then we had 1/4. I just want to review this real quick because we talked in class we don't have to go up each time. So we can keep that 7/20 alone. And then 4 times what gets us to 24 times 5. So at the top we got 1 times 5, which is 5. Then how about over here? 10 times what is 20? 10 times 2. So we got to do 6 times 2. So we could think about 12/20 plus 7/20 plus 5/20. Let's see, 7 plus 5 is 12. 12 plus 12 is 24. So we could think about this as 24/20. And again, we know we're going to have an improper fraction. So we could think about that as like 20/20 plus 4/20. So there's going to be one whole. So we got 1. And then we can simplify this, divide both these by 4 to get 1/5. Sweet. So either way, yes, Julian's sister is correct. I just want to show you a couple ways that we could kind of work through this one. So, do we agree? Yes. And then why or why not? You kind of have our work here to show us why it's right. So, and again, anyway, just reviewing getting common denominators. On our next page, we are looking at doing some rounding. Now, the biggest thing, and I'm going to actually edit this real quick. I think it's funny how they had a 0 here. Because we've talked about in class, the rule is whatever place we're rounding to, that's where we stop our decimal. So if I'm rounding to the nearest 1, or the nearest whole, I'm going to look at that number. We're going to look behind it and see what we have. And the rule is 5 or more, our number goes up. Because we're at least halfway to the next number. 4 or less, we're just going to stay the same. So right now we're at a 4. I see an 8 next door. So right now what we're asking is, and I'll even draw a little number line here. So for this example, we want to know if we had a number line, and let's say this was 5, and this was 4. And right now we're looking at 4 and 8/10. Well, right about the middle would be 4 and 5/10. So 4 and 8/10, be somewhere around here, 4.8. So is 4.8 going to be closer to 5 or closer to 4? Well, we can see it's going to be closer to 5. So the answer is 5. And instead of drawing a number line each time, the rule is if that number that behind it is 5 or more, we're bouncing up to the next number. And that's why we did in this case. So we start with the 4, we go behind it, go next door. We see an 8. What's the 8 going to tell us? Hey, bump that 4 up to a 5. Cool. So that's kind of the idea there. And then, let me just back it up. Now it says to the nearest 10th. Again, whatever place we're rounding to, we start there, go next door, boom, boom. I see a 6. 6 is going to tell that 8, yeah, bump up. We're at least halfway to the next number. So now it's going to be 4.9. And that's how we got that 4.9. So we write whatever number is in front of it, but then we stop at whatever place we're rounding to. Okay. And then the nearest hundredth, again, we go to the hundredth spot. Remember, it's tenths, hundredths, thousandths behind it. And we go next door, boom, boom, knock on the door. We see a 2. Well, there's only 2 there, so we're going to leave the 6 alone. Again, right now we're seeing, is this going to be closer to 4 and 86 hundredths or 4 and 87 hundredths? Since we're only a couple thousandths, that's not much. So we just stay at the 6. Okay, so let's take a look at, let's go with letter B. He can be a little tricky. And I like that we have more than just one whole number, because when students see the nearest 1, again, this is in the ones spot, right? So if I go next door, boom, I see a 9 over here. What's that 9 going to tell the 4 to do? We're going to bump up to a 5. So this is going to be a 15. Because 14.9, again, if we have 15 and 14, whoops, not 15 and 15. That 14.9 is going to be really close to that 15. So when we round it, we're going to say you're basically at 15. So we're going to make you're closer to 15 than you are 14. So that's, again, why that works that way. Just going to clear this up so I can leave some answers here. Nearest 10th. Okay, I go over to my 10th, and I go next door, and I see a 6. Okay, so 6 is 5 or more, so it's going to bump that 9 up. But if it's already a 9, well, that means it's going to go up another 10. So this is going to become a 0, and we're going to have to add 1 over here, so it's going to be 15. And that's why I wanted to show you this one. It's a little bit trickier, not too bad. But anytime you have a 9, that's actually going to go to a 0, but then we've got to bump the next number up behind it. Because what we're saying is 14 and 96 hundredths, that's closer to 15 than it is the 14 there. So what we're going to do is make that a 0. But if we go up, we got to go up one more on the next one. So 15.0 is going to be what we're looking for on that. So this is one of the cases where we do want to have a 0 here, because that 9, when it goes up to 0, we got to bump the next number up too. Nearest hundredth, we get a 6. Go next door, we see a 4. 4, he's not enough to bump up, so we're just going to leave it alone as that 14.96. Okay. So again, that's the idea, is just starting there and going next door. And we're going to do quite a bit more rounding throughout this packet as well. Number 7, just writing the fraction and the decimal. So again, 3/4. One thing you can do with a decimal is always thinking about what it is out of 100, or tenths, if that works. In this case, 4 times something isn't 10, but you know what? We could think about this as something over 100. 4 times what? 4 times 25. Do the same up top. 3 times 25 is 75. So 75 hundredths. And as we use the decimals and stuff more, they kind of remember some of these. What is the name of this? This is 20 hundredths. So we could write 20 hundredths. Again, like we mentioned earlier, students might ask, can we simplify that? Sure. We could also divide both these by 10 and get 2 tenths. Either way, that's what I think about. 3 hundredths, 3 out of 100. 3 hundredths, what would our decimal be? 6 tenths. So if we're starting with the fraction, just say it and just write it. And then this is 72 hundredths. Again, just understanding what those numbers mean. All right, number 8. Let's see. Riley collected rain for several weeks in his rain gauge. He collected 1.48 inches the first week, half as much the second week, and 1 inch the third week. Now, how much more does he need to get 5 inches? So we talked a little bit. Let's set this one up. We got 1.48 inches to start. Then it says half that much, so I'm just going to write 1/2 times 148 for right now. We'll take a look at how we can break that up. And then it says 1 inch the next week. And it tells us how much more do we need. So we know we're going to have to add some more. So we'll kind of put a mystery box. And we want our total to be 5. So this is kind of where we're starting at. So again, 148, half of 148, and then 1, and then we got to add some more to get to 5. So obviously, we just got to figure out what's half of 1 and 48 hundredths. You know, and we can break this down a couple ways. This 1, what's half of 1, students were like, well, that'd be 5, 50 hundredths or 5 tenths, half of 1. And then what's half of 48? Well, 24. So let's just see what that is. So we can break those apart. Let's see, we get a 4 and a 7. So that tells us, okay, that's 74 hundredths. Cool. So now we've got 1 and 48 hundredths plus 74 hundredths plus 1 plus something is going to equal 5. All right, well, let's go ahead and add these up real quick. We got the 148. We just figured out that was 72. Make it a little better A for you. We figured out that was 74. And then we got to add one more. Again, it's all about lining those decimals up. That 1 we can think about as just 1 and 0 hundredths if you want. 8 plus 4 is 12. 7, 8, 9, 10, 11, 12. And then we get 3. So we've got 3 and 22 hundredths plus something is going to equal 5. Well, what can we do to get that something? Really what we can do is just subtract, right? If we know we have 3 and 22 hundredths, we got to add some more, or maybe you want to kind of add it up in your head. However you want to do it. I'm just going to set up a subtraction because we can think about that 5 as 5.00, right? Minus 3 and 22. Well, we got to do some regrouping here. So that'll make that a 10. Then we need to regroup again. So again, 10 minus 2 is 8. 9 minus 2 is 7. And 4 minus 3 is 1. So it looks like this should be 1 and 78 hundredths. Now the nice thing is, with this type of problem, is we can check our work. So really, we should know if we got it right or not. Let's just double check our work. So is indeed this 322 plus 178, does that get us back to 5? 8 plus 2 is 10. 7, 8, 9, 10. 3, 4, 5. We get, yep, it works. So that's what we're looking for there, is that 1 and 78 hundredths. So just start with what you know to figure out what you don't know. All right, up next, we are writing an expanded form. And again, the whole idea is each of these numbers is worth something. So let's look at our example here, 25 and 893 thousandths. And we usually start by just saying the decimal and then breaking it apart. What does each part mean? That 25, well, that 2 is 2 times 10, and that 5 is 5 times 1. That's what makes 25. And then 893 thousandths. Well, it's tenths, hundredths, thousandths. So 8 tenths would be 8 times 1 tenth. 9 hundredths would be 9 times 1 hundredth. And 3 thousandths would be 3 times 1 thousandth. Again, it's just matching those parts together. Okay? In fact, just for heck of it, let's do a little color coding here. So we got 2 times 10, that's the 20. The 5 times 1, that's 5, right? Then 8 tenths, that's 8 times 1 tenth. 9 hundredths, that's 9 times 1 hundredth. And 3 thousandths, that's just 3 times 1 thousandth. That's all we're doing. So let's look at this first one here, 7 and 43 thousandths. Well, how did we get 7? That's just 7 times 1. In this case, we didn't need to multiply by 10. Now, we have 0 tenths here. So in class, they asked, do we need to write it? I said it's a good idea to write it. Technically, you don't have to. It's not going to change your answer. And later, they won't write it. So it's really up to you at this point. If you want to write it to start, we could write 0 times 1 tenth. Or you technically don't have to because it's not there. 4 times 1 hundredth, right? 4 times 1 hundredth Tell you what, let's keep the same color going. What did we do for ones? That was yellow. So again, the 7 times 1, that's how it got us to 7. And then I'm going to put 0 times 1/10. You don't have to write it, but if you want to just think about what does that 0 represent as 0 times 1/10, then what's the next? We got 4 hundredths. So it's going to be 4 times 100th. And then finally, we have 3 times 1,000th again. 3 thousandths. So all we're doing is thinking about what each number represents on that decimal. And then just reverse for this side, 3 times 1 would be 3. 6 times 1/10 would be 6/10. 1 times 100th would be 100th. And 3 times 1,000ths would be 3 thousandths. 3 and 613 thousandths. 3, 6, 1, 3. Just breaking those apart. And then we've done this quite a bit. This is just where you just write out the words. 1 and 893 thousandths. That's what they wrote. 1 and 893 thousandths. Again, we're just matching each part. To that. And we know it's in the thousandths because it ends in the thousandth. If you look at all of our examples so far, these all end in the thousandth space, and even the written ones. So all of these are going to go to the thousandths. 2 and 2 thousandths. Let's talk about that. So 2 and, so that tells us and is where the decimal goes. 2 thousandths. Well, I don't want to write my 2 there. That's 2 tenths. So I'm going to put some zeros to 0 placeholders here. What's up here? There we go. If I do that, now I have 2 hundredths, so I'm going to need another 0 placeholder. Let's see, is that right? 2 and 2 thousandths. Tenths, hundredths, thousandths. That's what we're looking for there. Number 3, list all these decimals in order from least to greatest. So we still got to figure out this guy here. But once we have all of those, then take just these decimals and put them down here in order from least to greatest. So start with the smallest and then work your way up. Okay. All right. And I can tell you, we'll go ahead and write this real quick. 40 thousandths. What would 40 thousandths look like? Well, there's no hole. And I want 40 to be end in the thousandth spot. So if I just write 40, that'd be 40 hundredths, tenths, hundredths. So we are going to need to put a 0 placeholder. Now let's check 40 thousandths. I see 40. Does it end in the thousandth space? It sure does. So these are all the decimals you need for number 3. One thing I sometimes do is I say, let's start, is there one that we know for sure? Do we have a lowest one or a largest one? 1 in 893 thousandths, 600 thousandths, 1 in 503 thousandths. Well, only one of them starts with a 2. So we know that this guy is going to be our largest decimal down here. 2.002, okay? And then how about our smallest one? Well, it's going to have 0 for our whole number. So we got 600 thousandths, 37 thousandths, 40 thousandths. Well, that 37 is going to be the smallest, isn't it? So we'll get you started there. We got our smallest and our largest, and then go from there. Now we get to just practicing with rounding. Just practice with the rounding. And again, number 1, all these are going to go to the whole number. So I'll start with my whole number. I have a 9. Behind it, I see a 7. 7 is 5 or more, so we're going to bump that 9 up to a 10. And that's all we're doing on this one. It's just looking at that. And to see if there's really much tricky. Not yet. Okay, nearest 10th. Again, start with our 10th spot. Go next door. I see a 5. 5 or more, we bump it up. So we're going to make that 6 go up to a 7. 1.7. Howdy.
How was the sidewalk out there when you walked in?
I think it was pretty clear. I didn't really, yeah, it was pretty wide open from what I could tell. Yeah, coming that way. Yeah, I think we're good.
All right.
Awesome, thanks. Yep.
Yep.
Here this morning, custodian Sue is just making sure our sidewalk's good. So the nearest 10th, just start with the 10th and you look behind it. And none of those are really that tricky. Now this is challenge. Let's see, are these really challenging? I don't really think so. Let's see. Nearest 100th. Well, let's go to our 100th spot. We see a 5. I see a 1 behind it. So if it's just a 1, we're leaving the 5 alone. So we're going to write 35 hundredths. Again, we end at the place we're rounding to, and then we have to write all the numbers in front of it. Let's see. No. See, none of these are tricky. I don't even understand how that's a challenge, but you guys got this. And then just some good old adding and subtracting. Again, great things to practice. 4, they stacked them for us. 5, they didn't. So, you know, if we stack these up real quick, 998 minus 253. 8 minus 3 is 5. 9 minus 5 is 4. 9 minus 2 is 7. Boom, we get 7 and 45 hundredths. All right, a couple pages left here, some story problems. Rachel has $10. She wants to buy a book that costs $6.79. Will she have enough money left over to buy a pen for $3.50? Well, let's just at least set this up. We've got $10. And again, it's all about lining up those decimals. That's the biggest thing. So if I have $10, I spend $6.79, will I have at least $3.50 left over? I don't know. You have to figure that one out. Diego has $3 bills, 3 quarters, 1 dime, 7 pennies. Sam has $2 bills, 5 quarters, 6 dimes, and 9 pennies. Who has more? How much more? Well, again, you know, kind of set this up however you want. Diego's got $3 bills, so that's going to be $3, right? 3 quarters. How much is 3 quarters worth? Well, that'd be 75 cents, right? 1 dime and 7 pennies. So again, just kind of thinking about our money here. We can put a 0 in front of these. And then how about Sam? Sam has $2 bills, 5 quarters. Well, let's see, 4 quarters make $1, so it'd be $1.25 in quarters, right? Okay. 6 dimes, that'd be 60 cents. And 9 pennies, that'd be 9 cents. So just got to add these up. See who has more and how much more. And then you need to add how much they have all together. All right, number 8 here. Just reviewing some volume. She's got a box. Again, you don't have to draw a picture, but again, if it's maybe 12 by 7 by 19, you know, we got a box here, something like that. So 12 by 7 by 19. What's the volume? We just have to multiply these numbers. 12 times 7 times 19. You know, you can multiply in any order. I might start with 7 times 12. If you kind of forget what that would be, we know 6 times 12 is 60, right? Plus another 12 would be 72. We have started talking a little bit in class about standard logarithm. That's going to be really coming up after our winter break here, after Christmas break. So 7 times 2 is 14. 7 times 1 is 7, plus 1 is 8. Yep. So that's what we get for that part. And then we got to multiply by 19 from there. So sorry, just checking a couple messages from the teachers. Oh yeah, I'm sorry. I was thinking 12 times 5 is 60 and then a couple more, but yeah, we get 84 there. Now we have to do 84, if you go this route, 84 times 19. And last year especially, we've talked a lot about, in 4th grade, they talked about this area model here, and we started reviewing with this here too. 84 we can think about as 80 plus 4, 19, 10 plus 9. And now that we know these parts, hey, what's 80 times 10? What's 10 times 40? What's 80 times 9? And what's 9 times 4? You can kind of go from there, okay? Again, if you have any questions, we can go over this in class too. Eric's keeping track of rainwater. On Monday, it rained 1 3/4 of a centimeter. On Tuesday, it rained 2 1/8 of a centimeter. How much more did it rain on Tuesday than on Monday? Okay, well, we just got to find the difference, so we're going to just do a little subtraction here, aren't we? So we've got 2 1/8 minus 1 3/4. Well, part of it is we need to get common denominators, right? So we can keep that 8, so 2 1/8. And then we know, hey, 4 times 2, that's 8. So do the same up top. 3 times 2, that's 6. So we can think about this as 1 2/8 minus 1 6/8. So we got 1/8 minus 6/8. Can't do that, right? If I have 1/8, I can't take 6/8 away. So we're going to have to regroup this a little bit. Let's break this 2 apart. We could really think about this 2 as one whole, 1 plus 1 plus 1/8, right? But this 1 here, we could really think about that as 8/8. So 8/8 would be the same as 1. So really 8/8 plus 1 more 8th, we could think about that as 1 9/8. Gotta run in room here. So we can think about that as 1 9/8 minus 1 6/8. Now that we've got this broken down a little bit, now we can do 9/8 minus 6/8, okay, and then kind of go from there. So just think about that, guys. And I think this is our last page. Again, just some more rounding to the nearest tenth. Start in the 10th spot, look next door. I see a 5. 5 is going to make that 8 go up to an 8, so 8.9, okay? Nothing really crazy here. Here's 100th, 10th, 100th. We see a 7, 5 behind it. What's the 5 going to tell 7 to do? Go up to an 8. So 24.28, 24 2800ths. Yep, nothing crazy. This is the only one. We'll look at 4C. Not that it's that tricky, but let's take a look. Where I have a 9 in my hundredths, I see a 5. What's the 5 going to tell the 9 to do? We got to go up. But if I go up 1, really, we're making that a 0, and then we got to add 1 over here to make that a 5. So I mean, the only thing that's a little tricky is, if we do that, that's going to make that 9 go to a 0, but we got to add 1 more to the 4, so we're going to get 3.50, 3 50 hundredths on that. Make sure my handwriting is legible. So not too tricky. Then add or subtract. Again, I'm stacked for you. Isabel is building a tree fort with the base 74 inches by 92 inches. What's the area of the base? And again, for this one, we're just doing that 98 times 90, or 78 times 92. We can just break that up. That 78 is 70 plus 8. 92 is 90 plus 2. 70 times 9. Again, 9 times 7 is 63. Place a 0. 90 times 8. Well, 9 times 8 is 72. Place a 0. 70 times 2. 7 times 2 is 14. Place a 0. And then 2 times 8 is 16. So now that we know our pieces, we can simply just add these. And you're good. Now it says, what is it in square feet? So the top one was inches, and the second one says, what is it in square feet? But I told students, I'm not too worried about that part, so we'll talk a little bit in class, but you can get rid of this, okay? So again, the whole idea is if we know it's 78 by 92, the area is just, I meant to write the formula up here, area is just our width times length. I wrote base times width, and math are kind of universal. It's kind of the two sides, right? So width times length. All right, guys, if you have any questions, let me know.